Hi, welcome to today's tutorial. Today I'll be guiding you through the process of using the climate predictability tool to forecast for amount of rainfall a particular place would receive based on the relation or the influence of sea surface temperatures. And to start, you would need to take note of the two variables I mentioned, sea surface temperatures and then its influence on rainfall amount at a location, and then how it will influence it, using the influence and the relation to make predictions. But first, we need to keep our data somewhere we can easily have access to. I like to keep my data on the desktop in a folder I've named CPT data. Then within the folder, I have four other folders. One named predictor handcast. The predictor's handcast folder carries data for the sea surface temperatures. Observation carries data for weather stations across the location whose rainfall amount you are trying to predict. And then the forecast predictors also carries data for the sea surface temperatures. But the difference between the forecast predictors and then the predictors handcast is that predictors handcast takes past data, that's observed data for the sea surface temperatures, and then the forecast predictors takes predictions for the year you are trying to predict. So that would be the year 2025. And then there's some additional folder named figures. This is where I keep all the folders, and this is where I keep all the maps I've made at the end of the day. So let's start by launching our climate predictability tool. This is the interface for the climate predictability tool. To start using this tool to make your own predictions and forecasts, you start by selecting View, and then you choose Canonical Correlation Analysis. After choosing CCA, the interface will change, and then you have three different options here. You have predictors X, predictors Y, and new predictor Z. Predictors X would contain data or would carry the data for the sea surface temperatures for the past. Predictors Y would contain the data for rainfall amount, and then predictor Z will contain new predictor Z will contain predictions data or forecast data for the sea surface temperatures. So to start, we select Browse on predictors X, navigate to where you get your data, get mine on the desktop, predictors handcast. So let's make the predictions using the CFS version 2 sea surface temperatures handcast data for the month, the 9th to 11th month between the year 1991 to 2020. So we select this particular data. After that, we get a new pop-up menu telling us to select a specific location on the sea or in our oceans which we would like to determine its influence to the rainfall amount received at the location under study. So let's draw here, select redraw map and select OK. Now you get a new pop-up menu asking you to choose the number of modes. Let's choose 3 to be on the safe side. After this, the next thing we will need to do would be to set or choose the input files for predictors Y. You select Browse, navigate to where you get or you saved your data. This time you'll be using observation instead. So select observation data. For rainfall amount, you use this one basically. The others are for rainfall onset and then rainfall cessation. so rainfall amount. And you would need to input the coordinates for Ghana since the observation or the observed weather stations which collected the data on rainfall actually found in Ghana. Select redraw map and then OK. The number of modes you are choosing for this one should be the same as the ones you chose for predictor X. Then once again, select 3 again. So after selecting 3, you realize the number of stations used actually 48. Number of stations are 48 and number used not yet. It's still 0. We need to make some few settings to set them. So the next thing will be to choose the forecast data. See, for now it's actually set as the same one used for predictors X. However, the year is actually in the past, so you need to use uh, data that represents a forecast. So after opening, you actually end up in the predictors hindcast folder. You go back and then you choose forecast predictors for the same time period, for the same data set, and then but for 2025 instead. So now it's the same data sets, TFS version 2, sea surface temperature, the month of the 9th to 11th month, and yeah, from 1991, and then this time it's 2025 instead. So the next thing you need to do is make sure the data you are using is actually accurate, and then you need to make some text. So you select zero bound, make sure that the data used for the procedure doesn't include any data below 0. Yes, and then transform Y data. So after that, select actions, calculate, and then cross validate. You get a warning. Just choose yes. Because we chose 3 modes, it will run 3 different times. This is the last time it's running. After this, we should get our results. Yes. So you realize that the number of stations used are actually 45. All the number of stations recorded were 48. This means that some of the stations did not meet the requirements we set, like making sure that the data is actually zero bound, and the other one that's transforming the Y data. The same goes for the number of road points. It changed a little bit and it dropped by 1. To continue, we need to start with our skill map. Skill map will help us know the relation that exists between the sea surface temperature for that recorded or for that selected area and the various towns or various weather stations in Ghana. So for now, we are using the Pearson's correlation, and it's on a scale of -1 to 1 with negative correlation and positive correlation. So negative correlation means that The specific surface temperatures or the location we selected on the sea surface, the temperatures that are out of phase with rainfall amount received here are these particular weather stations, and the positive ones means that they are in phase, signifying a significant influence on it. So let's look at a location like a scene. We have a correlation of 0 minus 0.57, meaning that there isn't really that much of an influence on this specific location. We are mostly looking out for the positives. So an area like Wenchi, the amount of rainfall Wenchi receives is influenced by sea surface temperatures at this location, the location we choose. Then the Pearson correlation is 0.2642. That's a weak positive correlation. They are in phase, but the influence is quite weak. Quite weak. Same happens to Abri. Abri has a Pearson's correlation of 0.3053, indicating that there's a weak positive correlation between the area we selected at sea, the surface temperatures there, and the amount of rainfall received at Abri. You can change the title of the map by right clicking at any side and then selecting customize, change the title, and then you type whatever title suits your work. I mostly prefer to use name similar to that of the file I inserted in the predictors X. You can also save your image or your map by exporting it as any of these to a location that you prefer. I prefer to export mine to figures, the folder I created. The next would be to check the CCA maps. That will give us the full relation between the area at sea and then how it actually influences rainfall over the entire country. So you could see here, similar to the one we had, a relation on a scale of -1 to 1. And the total correlation, the canonical correlation is actually 0.29. And this means that the amount of rainfall received in the entire country is influenced by this area, but the influence is very, very weak. See, this is the area at sea we selected. Then this is the stations, the data we inputted for predictants Y, having data from the weather stations in Ghana. So these are what the weather stations actually found. And the influence of this area at sea on rainfall received is very weak. So the last thing we'll be checking would be making forecasts. To do so, you select tools, forecast, maps, and probabilistic. And then you wait for it to process. So I have a skill bar next to it with slightly red ones showing with below on the slightly red ones, green representing normal and blue representing above. This means that based on this the influence of this area, the area we selected at C on rainfall amount received in Ghana, we could make these predictions. So most of the towns in the southern part of the country would receive rainfall amounts below what they usually observe. Let's try Accra, the capital of the country. And then the probabilities of receiving rainfall amount below what is usually observed is 46%. So you can see here for normal is 29 and above normal is 25%. If you combine both for normal and below, you realize that the probability of getting rainfall from normal to below normal is very high. And then most of the towns located in the upper part of the country, let's try for Wale Wale, has a higher probability of receiving rainfall that's above normal based on its influence with the area we selected at sea. So the probability of receiving rainfall above normal is actually 44%, and then normal is 30. So if you combine both of them, you get a probability of 74%, and that's the probability of Wale Wale receiving rainfall from with a normal amount of rainfall to a very high amount of rainfall, above normal amount of rainfall, 74%. You could also change or customize the title of the map, and you could export it as well. So this brings us to an end of today's lecture, today's tutorial, how to use the climate predictability tool to make forecasts, and then check the relations between various areas at sea and observed weather at the various weather stations in a specific locality. Thank you.